So in this lab, we are going to be identifying an unknown liquid from its density. So conceptually, and how this relates to what you're learning in lecture has to do with the idea that we can use densities to identify liquids, or we can calculate the mass, we can calculate the volume, we can calculate whatever we need. And let's say you were in a situation, so I'm gonna leave it up to you to read like the premise behind this experiment, but let's say you were in a situation where you needed to determine like the difference, or you needed to identify two different solutions that kind of looked the same, like they were both clear and transparent, but you needed to know which one was which, so you would determine the density, and it's actually very easy. So that's what you'll be doing for this experiment. You're going to be determining the density for compound A1 and compound A2. So just an overview of what you're going to be doing. You're going to measure them in volumetric flasks. Volumetric flasks are pieces of glassware that have a line. That line is called a fill line. At that fill line is exactly whatever volume the volumetric flask is. So let's say it's a 50 ml volumetric flask. At the fill line, it's exactly 50 ml. So it's very, very accurate compared to a graduated cylinder or a beaker. It's meant to measure volumes. So you're going to measure them in those volumetric flasks to obtain the volume, and then you will weigh that volumetric flask before you have added your compound to it, and then after. And then from all that information, you'll calculate the densities of compound A1 and compound A2. So you're going to need your compound. So for example, this is the first part of the procedure, and this is just like a very summarized version. I want to leave a lot up to you, where you just explore using Chem Collective and just kind of play around with it, get used to it, because you'll be using it for almost the rest of the experiments. So here I kind of just summarized it very, very roughly, and then I'm going to show you a little video about how to actually go about using it. So here I'm gonna kind of walk you through just how to do one general like round of these measurements. Now it's gonna go a little bit fast. That's okay. What I want you to do is first watch the video and then kind of explore it on your own. Like, you don't have to take the measurements just yet. Just try everything out. Practice like pouring from your flask to your volumetric flask. Just practice things, and then from there you can refresh the page and just start your real experiment. So it might take a little bit trial and error for you to completely get a hang of working virtual lab and using the workbench, but I promise you, once you get the hang of it, it'll be fine, and from here on out it'll be a lot like smoother. So I'm going to play this and then just kind of walk you through what I was doing. Let me turn on my pointer. Okay. All right. Okay, there it goes. So I brought over my compound A1 to my workbench, and then I was going to the glassware to get my volumetric flasks ready. I moved two over to the side. I kept this first one out in front of me, and then I brought my scale out to my workbench because obviously I need that as well. I weighed my volumetric flask. All you have to do is bring it on top of the scales until it feels it, and then it'll show you the measurement. You record that, and now I am pouring my compound A1 into my empty volumetric flask. Now this is going to be the part that might be a little bit tricky. It's okay, you can pour back again until you finally get it. As you can see here, I poured past the fill line. So the thing is, you have to pour exactly where that fill line is in order to know that it's exactly 100 ml. So you can see me here pouring back into the flask and then pouring again back into our volumetric flask. Now I didn't get it exactly to be 100 ml. It was slightly too much. It's okay. Try your best to get it to be 100 ml. And then I weighed again with my compound A1 in there, and then you record that as well. So just another note about the volumetric flasks. They are a special piece of glassware made so that they have a certain line where that volume is exactly whatever volume it's like saying it is. So this is a 100 ml volumetric flask. So at that line, it's exactly 100 ml. That's why I'm saying you need to go exactly to that line. And yes, so from here you kind of repeat this process. You repeat it 3 times for compound A1, you repeat it 3 times for compound A2. So just make sure you kind of keep your stuff separate. Don't get these volumetric flasks confused. Once I'm done with this one, I would probably pour my stuff back and then kind of get rid of this one. You will right click it and then just click remove and then just work with the other two, just so that you don't get confused. So in terms of the data that you're collecting and then the applied exercises after, so you're essentially just follow the procedure. It tells you when and where you're going to be recording data, and then the table also kind of guides you through. Please record all the sig figs that the scale allows, so don't cut it off just for no reason, like record all of it. And then that's for part A and B. And then part C, you'll be calculating the densities using the data that you collected. Again, that's using our basic density equals mass over volume equation. And then you're going to present a little table for that information that you calculate. It doesn't have to be anything fancy. I just want to see the densities and see that you see the difference between compound A and compound A1 and A2. From there, you will also be answering which one was a neurotoxin, which one was a food preservative. Again, this relates to the objective stated in like the lab. So just go back and read that, and you'll understand what that's talking about. For applied exercises, part D, you're going to describe in detail the steps you took. So just how I was kind of narrating what I was doing in the video, you're going to do that, except you're going to write it out. And please be as detailed as possible. The whole point of me asking you to do this is so that I know that you know how to use it, use Chem Collective, and I know that you did it yourself. And then for part E, this is a conceptual question, so I'm gonna kind of leave this one open-ended. I don't want to give away too much, and I want you guys to just, if you like, the simplest way to put it is go Google it and see what information you gather from that, and then just kind of synthesize that and write it in your own words. You don't really necessarily have to cite anything because it's pretty well-known knowledge, and I'm not requiring any citations for this. Like, that'll be on the lab report where I require citations. So just, I want you to search things up and then just kind of think about it, understand it, write it in your own words, and that's pretty much it.